Hi everybody. At this point we looked at the whole process of calibrating and building our props and deploying them to Sketchfab, and we've been using mostly reality capture, though for our pipeline we also use a lot Metashape, and in this video I want to go through more details that are related to Metashape specific pipeline. For that, let's create a new prop build here, call it Octopus MS, meaning Metashape, so that we start from scratch essentially. Let's go to captured props. This is what we photographed before. Let's grab all our octopus shots, copy, go back, paste everything in here under prop and EOS folder. There you go, that's done. Now click Full EOS Files, and it will go ahead and rename everything and put into these folders that are easier to work with, and under each folder would have all our lighting sequences, and also you can see that everything is split nicely. Loop number 1, number 2, and number 3, and the total number of shots there as well. Then we call generate PG image, and that will go and generate setup images that are more suitable for photogrammetry process. Pre-processing step is complete. We can now go to our PG folder and make sure that yes, everything is in there, everything that we need. Let's start Metashape. Let's add those newly generated images from PG image, select all, edit. Now, just like with Metashape, with reality capture, we need to make sure that everything is assigned to the same calibration group. So we go to Tools, Camera Calibration, and make sure that it is a single group. Because what if you have something like that, where it's a separate group per image, then it's not good. Then we'll have the exact same problems as we discussed with reality capture, when those calibration and lens groups are not assigned properly. So we don't want this. We want to make sure that it's all assigned to a single group. Okay, now we run the align photo process. One important thing here is to click exclude stationary type points. That's primarily needed when you work with turntables. You would also have some background, and if you don't click this, then essentially it will use all those points that are all the same between different object flips and different loops, and nothing will get aligned. In this process we don't need any high or highest accuracy. Medium works just fine, and it doesn't take that too long. As you can see, for a prop like this, just 48 shots, it goes pretty fast. And sometimes when using high quality or highest, you actually get even worse performance there in terms of how not just it takes longer, but also it can fail to align some cameras and in general be less accurate. So it's again one of those cases when bigger is not better. And we got all our cameras in there. It's also very nice at this point to go ahead and make sure that actually all the loops are loops, and you don't have some cameras just flying around randomly So in this case I'm just selecting loops and making sure, yes, it's a nice circle here. So at this point, as we talked about in reality capture case, all these methods of optimizations, they're all iterative, and usually they have to start at some point, either when a certain precision is achieved or certain like iteration count is achieved, like maxed out. So in these cases it's always used to go to optimize cameras, and in our specific case we only support these types of parameters. So you need to make sure that fit X, K1, K2, K3, this is what in reality capture refers to Brown 3 model. With K4 it's Brown 4. There is also CXCY, P1 and P2. We do not support fit B1 and B2 coefficients. That is especially, I think B2 is very specific to Metashape, and it's not very common with other packages. So make sure you uncheck these three and everything else is unchecked. So when we run this step, you would see that something might change here a little bit. No, almost no change. Let's do it one more time. However, in many cases this would be enough to do, and this is not something that you can do in reality capture, at least not as easily as here. You can do that with masks, but what we essentially want to do, we want to remove at this point everything that's not, basically these type points that's not part of an object. And in that case, perform optimization one more time to make sure that we removed everything we don't care about, and that way we can achieve much more accurate camera alignment in case if there are problems. As I said, you don't have to do that. If you're lucky, then everything should be good there. But when we're building just some hero assets and you're okay with taking like a minute to do what I just did there, basically selecting those type points and removing them. Some of this stuff could also be automated with markers and with custom predefined objects, but essentially, as you can see here, we basically removed all the points that are not part of the object. And at this point, when we do optimization, you could see that some of that will change. Let me move window over here, click OK. Moved a little bit. So at this point, it again, depending on your scene and your camera, sometimes we would want to run it like a few times and make sure that nothing jumps there or keeps moving, because if something keeps moving, most likely there are some issues there with convergence of all the data and might not be accurate. So we can go to camera calibration and make sure that yes, everything here looks reasonable. I mostly look at these CXCY parameters, because sometimes when those shift happens, those are the parameters that are responsible for that, and you would mostly see that type of behavior when you build those single loop things. So in here everything looks good. We optimized it a few times. At this point, before we build the model, again, it's useful to go ahead and align this reconstruction region a bit better with the model, so it doesn't spend extra subdivisions where it's not needed. Again, this step with a pro version could be all Python scripted and so on. Here we're using just simple, relatively old 1.74 build of Metashape. That's a standard edition, meaning that it doesn't have any of those scripting or marker related features, so it's the most basic one, and we can see that we can still build high quality props even with this version. So let's fit it a bit better. Again, it's not necessary to do that, but it helps when you just do this hero props. important thing is that we don't transform the object in here, because we have a model transform object functionality. Don't use that. We currently don't support it, because everything that you've seen me do here before, that was just modifying reconstruction region. So make sure that on this chunk you don't have any T letter that stands for transform. At this point, we got all our alignment. We can go ahead and save this model, this project. Let's call it Octopus Metashape. Well, it is Metashape. I will save it in PCZ format. That's just the compressed one, so that everything it takes a bit longer, but everything stays within the same file. That's done. At this point, we can go ahead and also export our cameras, because we won't be modifying them anymore at this point. Octopus MS PG cameras, just override that file. Done. So now let's go ahead and build our high poly model. Yes, depth maps, and we'll use medium quality. For now will be more than enough. Just make sure we enable extrapolated and aggressive depth filtering, but this could really be anything. It's mostly when you have more missing spots, then aggressive would kind of fill them in better at the cost of losing some of the definition there in the model around edges and things like that. But because we're building the photometric data, it's gonna store all that realistic data in textures, so we care a bit less about the actual geometry here. We'll just, for this tutorial, stick with medium quality, use depth maps, make sure that face count is set to 0, so it essentially will spit out the original data that would be, the mesh would look very similar to what you get from Marching Cube's mesh reconstruction algorithms. So everything looks good here. We don't need to calculate this vertex colors, because usually that takes longer, and we want to clean up the model before that anyway. Click OK. There you go. Our mesh reconstruction with in medium quality is complete. We got around almost 7 million polygons here. As you can see, compared to reality capture, there are no fuses there. So yes, it's there are some things that are flying around, but at this point it would be a lot easier to do the cleanup and remove all those extra things that we don't need there. So that should be pretty quick. That is done. There you go, and that's pretty much it. We would call it our high poly mesh, but before saving it, when we reconstructed the model, the mesh, we specified this face count as 0 there. And what that means, if we now switch to model wireframe, you could see that there is this, you have kind of denser regions, you have less dense regions, and you have this really tiny polygons. And so this is consistent with what's called the Marching Cubes types of algorithms. So before we start doing anything with this mesh, we don't really need that, and usually it's a safe thing to say that we can decimate it to like twice the size in terms of face count easily. Let's go ahead and decimate mesh, and we had 5.5 million. If we divide that by 2, so let's say 2.8. let's make it 2.8 million. Okay, yeah, replace it. And as you can see, all those little polygons are gone, and you pretty much get the same definition there. Another thing that I like to do that you don't really need to do there, but usually we like to apply what's called the median filter to these high poly models, and in Metashape essentially they call it under advanced option preserve edges. Smooth mesh, preserving edges, and you have some strength. But essentially what it will do denoising, but it will generate new vertices that would only have the same coordinates that are already present in there. It's very similar to median filter in Photoshop. That's very good for denoising and removing all that noisy stuff. So now it looks a bit chunky. That's good for low poly model. So we want to smooth it out a little bit using regular smoothing without preserving edges. So well, that was a little bit too much, but that's still okay. And that's going to be our high poly model. So I probably should have used 0.5 there. At this point we can go and export this one as PLY, high poly, Vertex normals, confidence, yeah, sure, click OK. That's good. And now let's generate our low poly mesh. The easiest thing to do is obviously to just downsample that, decimate it to your final target right away, and that's one way to do it. But usually if you want to allocate more triangles on edges and fewer triangles in this smoother regions, you'd have to do it in multiple steps. So let me show you what I mean. So if we have 2.8 million, then first we go to 1.4 million polygons on the same mesh. Then we do it once again. What is it? 700k. Okay. Yes. Then we go to 400k. Yes. And then 200. And finally to 100. Yes. And if we compare this to models, we would see that we would generally have more definition around these smaller things. And fewer triangles where we needed the least. Let's call it our low poly mesh. Go ahead and build textures on it. As with the reality capture, where you can just run unwrap there to generate UVs, with Metashape, at least with standard edition, the only way to do it is to actually build texture, even though we don't really need that texture. So we just select the blending mode average, 8K, one texture, and click OK. So we don't need any of that filtering because we don't really care about this texture. So there you go, we have our texture build. At this point we can quickly go ahead and inspect it and make sure that there is no obvious blending problems. That sometimes can happen if your registration was not very precise and you had those camera outliers. Normally you would see like completely offset some other image that goes across the model, because when we use the simple blending of texture, it doesn't check any photo consistency. So if you had one camera that was completely off, you would see it right away here. Just quickly looking at it, everything looks pretty fine there. I don't see any problems, and we did check those loops before. So now they just go ahead and export this model, and now we will export it as OBJ, low poly, override that, yes. Don't use UDIM, just export texture, yes, because if we don't do that, it will not save UVs. Vertex normals, yes, okay. So everything is done. Let's make sure that we exported our registration. Yes, we did. That was exported. Just to make sure it's export cameras, and we just, yes, it's already non-zero, but to be sure, click yes, and at this point we can close our Metashape. So we got our low poly, we got our high poly. As you can see that in this workflow using standard edition Metashape, we didn't use any ground control points or anything like that, so we still need to have that scale for photogrammetry. So we just run our marker info script. It says that the size is not defined. Marker size, I've showed it in previous videos, but just to be sure, that's what you measure. You put these markers, you measure this size of this black region within them. In my case here, we can see that it's 7.9 millimeters, and we measure everything internally in millimeters. So in here, 7.9, and I save it. If you don't want to do it every time for every model, you can always go ahead and under your props modify your template directly in here, so that this way you don't need to type it every time. It's really up to you when you do it. So at this point I just run the script. It goes through all the photos, it finds all the markers, it does all the calculations, so it figures out the proper scale, the proper exposure compensation and everything, and it modifies this default solve script parameters. At this point we're pretty much done with the photogrammetry part and all alignment. Now go to prop, go to solve. Let's run our res info script that will go ahead and calculate what the optimal resolution for this texture build would be, assuming that your textures have that sharpness at like per pixel level. And it's pretty much the same here as we had with reality capture. So the optimal would be 8K. All cameras there look consistent. Sizes, bounding boxes of the mesh also look about what the actual size of that prop is. So all that looks pretty good. If we open our parameters, we can see that that was our auto scale set, auto exposure, and distance to the plane. For this specific build, we also want to modify a few things as we did in previous videos. So we know that it will build an 8K texture with an 8K tile without any problems. So let's just specify that. We also want to use that mask, and I'm gonna show you that in just a second. And we'll also disable this normal correction that makes sure that the generated normal map is robust in different renders, but it will take a bit longer to build, as we've seen in previous videos. Again, we can disable this for now. It's not that important for this demonstration. Regarding that mask, let's have a look at that. So let's launch our project again, and in this case we know that it's loop number 3 that we want to modify. And it's also nice that in Metashape you can quickly go and increase intensity of these images. That's just for preview, where we can see where all the stuff is. To do the same stuff as we did in reality capture in Metashape, essentially what I like to do is to disable all cameras and then enable only the loop, cameras of the loop that we want to build. So enable cameras, go to workflow, build mesh, medium quality is fine, and in here we make sure that we reuse depth maps. So this will this way it will take much faster to build just this one single loop that we can use for masking. So there you go, that build is complete, and we can see that we also have in here pretty nice model of those extrusions, so this is more than enough quality to build those masks. Now we can just go and I'm using shortcuts and export this mesh as PLY. Now we go to OCC, that stands for occlusion, copy that loop, call it O3, and override that high poly mesh with this one. Yes. And also let's export cameras, so we're already in that folder already. Override cameras, yes, and now we can close it. We don't need to save anything or anything like that. So now let's go to that loop 03, open mesh lab, fill everything white. Now select everything that we don't want. That should be good enough. Let's fill it black. So, and as you can see, we got the same thing where when this extruded part would pass in front of the object, it would automatically be masked there. So we just go ahead and export the mesh, make sure that color and normals are enabled. Done. Now click render masks, so we don't need to run any other scripts here, just render masks. Just exported all the masks. We go to masks folder, and this is the same stuff that we got using reality capture. So we just cut them from here, paste them under this masks folder, and we're good to go with building our 1K texture to start with. Go to scripts, 1K, build. As you can see, everything is good. All our masks get loaded, so all that occlusion would be handled properly there for that specific region. And our 1K preview is complete. Now let's do the albedo fix-ups. Let's bake our AO so we can also run a test deploy there. At this point, pretty much all the data would be exactly the same as with reality capture, just different UV mapping, but other than that it would be exactly the same. Now we just click preview, it will open Blender and set everything up for us, so we can now just inspect the whole materials, move lights around here and see how everything reacts. We can inspect all our textures that we build, our roughness, reflectance, colors, and also look at our confidence map as well. Pretty much at this point, if we want to, yes, an AO of course, and at this point all we want to do, if we want to also export this model in this also nicely oriented and properly scaled form and be deployed, we have to go, well, first of all save the scene, then export that as OBJ, selection only, and we export it in the root of the prop as model.obj, and we export that model. Done. So now we can close it, and if we go to our params file, we would see that at the very end where it does the deployment, we would see that it will basically look for that specific model.obj, that's oriented file, and that's what it looks for by default. In this case, we target just Sketchfab, but we haven't looked at that previously, but let me also enable Unreal Engine 4 version, but that's essentially an older metallic pipeline. And one thing with metallic is that when you have very often kind of bluish patina like diffuse and at the same time golden yellowish specular, with metallic pipeline it's in principle impossible to get two complementary colors using just a single color. Like, you cannot create the yellow from blue or blue from yellow, and so we have two different versions there that run at the very end that try to either preserve that notion of metallicity or try to the best possible to preserve all the colors and all the rendering, but at that point your metallic texture, it means nothing. It has nothing to do with metal, because you can create, let's say, dark black plastic, which is the electric, by setting metallicity to 1 and base color to like very dark value, and in that case it would also be like a perfect plastic type of material, but it would say that it's 100% metallic. So in this case you can see that you can represent different materials, but you're gonna lose that notion of metallicity. So with that being said, let's go to, we got all our textures and everything here. Let's go to scripts, hit deploy, and of course it's a 1K texture just as a test. But as exporting specular pipeline, it will also run multiple steps where it generates different versions of this metallic one. And if we go to our deploy folder, we see that's our typical stuff for Sketchfab, and we had a whole video where we went ahead and uploaded that to Sketchfab and tuned everything to look exactly like in Blender, and we basically need to use just these materials. But if we go to Unreal Engine 4, here we would have a full set of stuff for kind of older version of metallic stuff, where we would have T model C, that's base color, and B means it's balanced version, and then we have M version, that's more like where metallic component is used as a free parameter. And as you can see, there is a difference between them, and it also generates automatically MSR textures, also two different versions, one that tries to preserve that separation between dielectrics and metals, but at the cost of some lost coloration, and also it's possible that there would be some artifacts between those material transitions, because technically speaking, metallic pipeline is not blendable. Like, if you want to represent a mix of materials, you cannot just take parameters and blend them, so that you cannot interpolate them in general case. So if it works, it works, but if it doesn't work, there's not much you can do there. There you go, we have two different versions, and also for Unreal we store as well the specular PBR version where it's _D, that's diffuse texture. You see it looks nothing like the base color, and we have a regular F0 specular similar to what we use with specular pipeline. The normal map is essentially the same. Roughness, again, that's for the specular pipeline, but for MRS in this case, that's where metallicity, roughness, and specular are all packed into the same single map as it's usually used with Unreal Engine of older versions, and AO just as a reference. at this point, it's pretty much we covered everything here. We talked about reality capture, the whole calibration process, the whole masking and occlusion type of pipeline and how to handle that, the whole Metashape thing. One thing I could also expand on is sometimes when you switch between reality capture and Metashape, some things work good in one and completely don't work in the other, and vice versa. So usually it's good to have both versions, or even Zephyr, like some third option where if something doesn't work, you can always switch and do the prop in a different package. In many cases, even with Metashape, we would use an older version like 1.7 along with much newer versions like 2.1 that's most recent, because they use different algorithms. You have different tweaks available there. And then on top of that, you might have cases like what I'm going to show you right now. So if we start, let's say, a Metashape, and we go to our chart prop, and that prop that we scanned only had 12 positions in a single loop. And in here, I've done it before. I can tell you right away that no matter what we do, there's no way to align it. So we will always, like some cameras would align it, just not enough. And reality capture did it without many issues, though we had some issues there as well. But in this case, I can go ahead and try all different set of parameters, different here, different there, different types of guided image match and not guided. Like we can try all different combinations with this particular set. We can also try different types of pre-calibration and so on and so forth. It will not work. So, but when we use this type of helpers there in all our scenes, that becomes very useful in those types of cases where you just cannot align something. And watch what we can do here. We can just go ahead and reset all our alignment, but let's grab some of those octopus shots in here with that same box. There's not much. We put it in a group so it would be easier to delete them later. And the whole point is that we add this helper images that also have similar stuff with what we have in this shot, but also something that doesn't overlap with it. So let's go to our shots that we built for the octopus. Let's just grab this first loop here that contains this prop, this box. Open. So now you can see we just added 16 extra shots. It has an octopus, but it has the same box. So, and now if we go ahead and align everything, exclude stationary points, click OK, and you would see this would work without an issue. And this is one also useful thing, to have those kind of standard objects that you always have in your scans that help you with automation and help you handle like edge cases and some tough cases like this. Whereas in this case, if we cannot align it, we can use another package, but the worst case scenario, we would have to go and rescan it, and sometimes it's not possible. So let's go ahead and remove cameras, and as you can see, we get all our loop of 12 cameras perfectly aligned, even though we couldn't align them before. So in this case, obviously we have to run this optimization step, and you could see, okay, it moved a little bit and then it stopped. So it's all good. So even though those things that did not align before, that little box, it helped to resolve those cross references between all these other shots, and now everything is pretty stable. We can go ahead to camera calibration and confirm. One thing that would be a little bit weird, and I talked a little bit before here in this video, is that these parameters, so this specifically CY parameters, so that's minus 1500, and the resolution of the image is like 6000. So that's pretty significant shift. There could be, and you mostly get that type of stuff with single loop things, so that might be a bit suspicious. Most likely it would build without issues, but when you see something weird like that where one of those offset parameters shoot like that in these cases, you might want to do optimization without it. So if we uncheck that, everything has to jump a little bit and move. There you go. But then if we keep doing it, now it's all locked and it's all nice. And if we go to camera calibration, we should see that, yeah, these are parameters set to 0, but this might be a bit more accurate just in this single loop case. So there you have it. Most of other stuff, it's pretty much we use standard Metashape without any of its extra features that are available in Pro versions, and we still build our prop with proper sizes, with proper orientation, and even better mesh resolution and quality there. So at this point, I hope you enjoyed this series. We might be adding some more extra, more advanced stuff, describing some parameters, but overall that's pretty much what you would use most of the time. And if you have any questions, feel free to ask in comments or email us directly, and we will be more than happy to answer those questions. And thank you for your attention, and I'll see you later.